Hello everyone, welcome to my YouTube channel. So in our last two sessions, which are part one of analytical functions and part two of analytical functions. So what we discuss in part one is what is analytical functions and what are different categories of analytical functions in detail. And then in part two, we actually discussed about the first category, which was analytical aggregate function. And we have seen all these functions with the help of one simple example. So you can just go through the part one and part two. And in today's session, we are going to discuss the next category, which is analytical value functions. Okay, so in this particular category, we have first value, last value, lead, and lag. So what first value will do basically, so analytical value functions are also called as navigation functions. Now, why navigation functions? Because these kind of functions assigns a value based on the value of a different row. So what we have seen in analytical aggregate function that they are considering current row also. So while calculating the current row with the help of analytical function, these functions will not consider the current row. Instead, for the calculation of current row, these functions will consider the different row. Okay, now how that you will see with the help of example. So what first value will do, this is going to get the first value of that window. So if you have passed a salary column here, okay, so what this is going to give, this is going to get the first salary. If you have sorted that data in ascending order, is going to get the first salary out of that window and assign into that particular window for all the record of that window. Similarly, the last value will get the last value of that window and will assign it to each and every record of that window. What lead will do, lead function will basically get the next value for that particular column. Okay, lag will get the previous value for that particular column. Okay, so let me just show you the data set and the expected output which you want, so that we'll be able to understand all these functions clearly. So this is the data set. These columns are the existing columns in my table, and these columns are the calculated columns which we have on which we have applied these four functions, and this is what we want as an output. Okay, so what is happening here? So this is the same data set I sorted on the basis of department number, because analytical functions works on the concept of windows. So this is first window, this is second window, third window, and fourth window. Okay, so if we just talk about the first window first, we have applied first value function in this column. So what is the first value here? It's 1300, right? So it has assigned 1300 to this bucket, this particular window. What is the first value in this? 800. It has assigned 800 to each and every record of second window. Similarly for department number 30 and similarly for department number 40. Now what is the last value? Last value of this window, 5000. It has assigned 5000 to each and every record. What is the last value of second window? 30,000. It has assigned 30,000 as a last value, and so on. Okay, what lag will do? Lag will get the previous value for that particular record. So when I'm calculating for this particular record, do we have any previous value in this window for 1300? So this window is starting from 1300 itself. We don't have any previous value, that's why it is coming as null. When the cursor will move to the second record, okay, how analytical function will calculate the value is, because we are applying a lag function, it will get the previous value, which is 1300, will assign it 1300. Similarly for the third record, do we have any previous value? Yes, 2450 is assigned to this record. Okay, when we move to next window, this will become my first record, right? Do we have any previous value for this record? No, that's why it has assigned a null value. Do we have any previous record? Yes, 800, and so on. Now what will happen in case of lead? Lead will get the next value for that column. Do we have any next value for this window, 1300? In this window, do we have any next value for 1300? Yes, 2450. That's why it has assigned 2450. Now cursor will move to second record. Do we have any next value? Yes, 5000. It has assigned 5000. Do we have any next value for 5000 for third record? No, this is the last record in this window. That's why it is coming as null. And similarly, it will calculate this lead function. Similarly, it will apply this lead function to other windows as well. Okay, so let's see how this will work practically, how we're going to write the SQL query for this. Okay, so this is my data set. So let's apply the first function, which is the first value. I need to give the argument as salary. Then I need to give the over clause, as we are partitioning our data on the basis of department number. So I need to pass here partition by clause. Department number. This will become my first salary in that department. Let's try to execute it. If you see, we have 1300 here, but it is assigning on the basis of how we inserted this data, right? If I sort it on the basis of salary, for department number 10, it is coming correctly because we have inserted data in ascending order. But for department number 20, it should be showing 800 as a first salary if I sort it on the basis of ascending order. So let's apply order by salary and try to execute it. So now we have got the same result which we have in our spreadsheet. So for the first window, 1300 is the first record. That's why it is coming at 1300. For the second window, 800 is the first record in ascending order. That's why it is coming as 800, and so on. Okay, now let's apply last value function. Instead of first value, this will become last value. We need to partition our data, and let's just try to execute this. I need to give this as last salary, last value. You see what happened? It is not giving me the last value. What is the last value for the first window? It should be 5000. What is the last value for the second window? It should be 30,000. But it is giving me the same record which we have in that column. Why this is happening? Because here we are applying. So first of all, let me just do one thing. What I will do, I'll create another column, department number. Let's say this is a temp column. I will just remove this order by clause here. You see, we have got the last value for each and every window which you want as a expected output. 5000, 30,000. This is coming correctly now after removing order by salary clause. When we specify order by clause in our over clause, okay, by default windows clause also gets applied. Okay, so what's the default window clause that gets applied? Basically, rows between unbounded preceding and current row. This is the default windowing clause will get applied to your function if we are using order by clause. Okay, so even if you don't mention this clause, this window clause, by default it will use if you have specified order by clause. Now consider how this is calculating now. What you want to calculate by default? Rows between unbounded preceding. What is unbounded preceding is, I want to consider all the previous rows and current row while calculating the current row. Okay, so what we are applying here is the last value of my salary. So let's just talk about this window first. I want to apply my last value function in this 1300. Okay, now I would be considering by default all the rows, all the previous rows. Do we have any previous row for this? No. Okay, do we have a current row? Yes, which is 1300. That's why 1300 is coming here, and that's my last value, right? Now when the cursor will move here, okay, it will consider, do we have any previous row? Yes, 1300. So the window will have only two records right now, which is 1300 and 2450. And out of these two records, what I want to get? The last value. Which is the last value? is 2450. That's why 2450 is coming here. Now the cursor will move here. Do we need to consider all the previous rows? Yes, I need to. Do I need to consider the current row? Yes, it will consider all three records. And what is the last value in this is 5000. That's why 5000 is coming here. That's the reason we are getting the same result as this. Okay, now when I have removed this order by, it will not apply this window clause here, and that's the reason we are getting the exact result that we want. Okay, now if we want to use this order by clause function, order by clause, and still we want to get the last value, what we will be doing? Okay, so instead of this considering current row, I would need to use unbounded following. That means every time I'm calculating any of the row, I want to consider the previous rows as well as the current row as well as the all the next rows. So I want to consider all the records in that particular window, and out of that I want my last salary. Okay, last value. Let's try to do that. Let's try to apply this here. I will write a different one. I'll just copy this. I'll mention this rows between. I need to give order by also. Give it as temp2, let's say. Let's try to execute this and we'll compare. So in this case also I have got the same result which I want, right? Because now I am telling my database engine that I don't want to go by the default Windows clause which we have, which is unbounded preceding and current row. Instead, I'm telling the Oracle engine or database engine that consider all the previous rows, consider all the next rows as well as the current row while calculating this last value. That's the reason we are getting the exact same value here. Okay. Now let's move to our next function, which is lead. Lead is going to give me the next value in that particular column. Let's apply a lead function on salary column. We need to give the partition over partition by department number. Order by salary. If I don't apply order by, it will give me in the order how they are inserted. Okay, but I want this salary to be populated in ascending order. Okay, this will become my lag salary department. Similarly for lag, this is my lead, this is my lag. Lag is going to give me the previous value for that particular record. Let's just try to execute this. Okay, so if you just focus on these two columns, which is for lead and lag. So lead is basically, if you consider these two columns, what we have. When my cursor is in the first record of first window, do we have any next value for this record? Yes, 2450. That's why 2450 is coming here. Do we have any next value for this as per lead function? Yes, we have 5000 in this window. That's why 5000 is coming. Do we have any next value for this record? No, this is the last record of this window. That's why it is populated as null. Now in case of lag, do we have any previous value for this? No, that's why it is populated as null. Do we have any previous value? Yes, 1300. That's why 1300 is coming here. Do we have any previous value for 5000? Yes, 2450. That's why 2450 is coming here. And similarly, it will calculate the lead and lag values for the rest of the windows. So this was about the analytical value functions or analytical navigation function. So let me just copy this and then we'll move to our last category, which is analytical sequencing function. So I'm going to paste all these queries in the video description later. So you can copy that as a reference, but first try yourself and then compare your query with this particular query. Okay, now we'll move to the next category, which is analytical sequencing function, or sometimes also called as ranking function, because these all the functions are going to assign a rank to our record. What row number will do? Row number is going to assign the rank to all the records in order, so it will not skip any value. Starting from the 1, if we have 10 records, all the records will be assigned value as rank as 1 2 3 4 5 6 7 8 9 10. In case of rank, if the same value is coming, it will assign the same rank for that particular value, for that particular record, and then will skip the next value. Okay, we will see that practically, whereas dense rank will not skip the value, so it will still assign the same rank for the duplicate record if the same value is coming, but for the next record, next different record, it will not skip the sequence. Okay, so let's see how these function works practically. Before that, we will see a data set. What is my existing data in my table and what is my expected output. So this is the data set, and these are the existing columns which we have in our table, and these are the columns for row number, rank, and dense rank. Okay, now if you look at this column, how it is calculating the row number value. So as analytical function works on the concept of window, and we are considering department number as a partition here, so we have 4 windows, same data set which we are already using, so it will consider 4 different windows as per the department numbers we have. Okay, now the first window, it will assign the row number, because this is not going to skip anything. It starts from 1 and sequentially we assign the rank to each and every record, so that's why it is assigning 1 2 3. Similarly for the second window, 1 2 3 4 5 6 7. Similarly for the third window and fourth window. Okay, so that's how row number works actually. So now let's talk about the rank and dense rank. What will happen in case of rank? If we will get the same value, okay, it will assign it a same rank, and then it will skip the sequence. Whereas dense rank will assign consecutive numbers. This is not going to skip the rank. However, it will assign the same rank to the same value. If the same duplicate value is coming, it will assign the same rank, but will not skip the sequence. Let's see how it is working. So in case of first window, we have all distinct salaries. We are not getting any salary twice, right? So that's how it has assigned 1 2 3 1 2 3 in both the cases, in case of rank, in case of dense rank. Now let's move to our second window. We have 800 1100 3000. So if you see this 3000, it's getting repeated, right? What is happening in these two records? So if you see in case of rank 1 2 3, now again we have 3000. It has assigned the same rank as 3 in both the cases. So rank has also assigned the same rank as 3. Dense rank has also assigned the same rank. But what is happening in case of rank? It is skipping the value of 4. 1 2 3 4 5, right? But in case of dense rank, numbers are consecutive. 1 2 3 3 and now 4. Okay, and so on. So that's how these three functions works. Now let's see how we are going to write the SQL query for this. So we will use the same data set. I will just specify the required columns: ename, department number, and salary. Now let's apply row number here. I need to give over clause, I need to give partition clause, So these things we already know now. Partition by department number. I need to assign a rank on the basis of ascending order of salary. So I'll just specify the order by clause and I'll give it alias as this. Same statement will come in case of rank also, but instead of row number, we will use rank here. Similarly for dense rank. Let's try to execute this SQL. So if you see, we have got the same result. 1 2 3 1 2 3 1 2 3 because we don't have any repeated salary here. All are distinct. In case of second window, just focus on these two values where we have repeated values in the same window and just compare the rank and dense rank. 3 3 we are skipping the next sequence here in case of rank, but in case of dense rank we will not be skipping the sequence. 4 will come here. So the only difference in case of dense rank and rank is dense rank is going to give you the consecutive numbers. Okay, so this was about the analytical ranking function. So let me just copy this query as well, and I will paste all these SQLs which we have tried in this session to the video description of this link, and from there you can refer these queries and you can try yourself. Okay, so what we discussed in this session, we discussed about analytical aggregate functions, and we have seen practically how these functions are working in our part 2 videos. And in today's session we discussed about the analytical value functions and analytical sequencing functions and how they are actually working practically. So I have used simple examples so far so that we will be able to understand the basic concepts clearly. Now in our upcoming sessions, we will try some case studies. We will try some scenario based questions. Okay, so that we'll be able to understand how these all functions are working practically in real time scenario. Okay, so thanks for watching my tutorial, and like, share and subscribe with your friends, whoever wants to be a part of this data engineering journey. Thank you.